Welcome everyone to the Inside Java Newscast, where we cover recent developments in the OpenJDK community. My name is Nikolai Parlok, and today we're going to look at a clever little addition to jcommand which will considerably broaden your debugging toolkit. Ready? Then let's dive right in. I checked earlier today and there are about 30 binaries in my JDK26 install, so I'm not assuming that you know all of them. I surely don't. One that I barely use is jcommand, jcmd, but that's just because I don't debug production applications anymore. If you do, jcommand is super helpful and you should look into it. With it, you can send diagnostic commands to a running JVM and get it to divulge all kinds of behind-the-scenes information. For example, to see the GC's finalizer queue, which is very handy in preparation for finalization's removal. To create heap and thread dumps, the latter are great to explore the thread relationships established through structural concurrency. Speaking of virtual threads, you can see what their scheduler is up to as well. You also use jcommand to configure, start and stop the JDK flight recorder. And there's much more from basically all moving parts in the JVM. All in all, jcommand is a really useful tool and I recommend you check it out if you haven't already. Or subscribe to this channel. I'll try to get Billy to do a Stack Walker episode on it. So let's talk about JDK Enhanced Proposal 528, which is a candidate but currently not targeted to any release. It may make it into JDK 27, but as always, we need to let the process play out and see what happens. JEP 528 describes how everything I just said is fine and dandy, but only works with a running JVM. And yet, you're very likely to need that exact information just after a JVM crashed. And by that I don't mean an application crash due to an uncaught exception or out-of-memory error, but a proper JVM crash.
Proper fuck.
Because somebody didn't use JNI correctly or found out where unsafe got its name from. If the JVM crashes, all you're likely left with is a core dump, and while you can extract some information from that with tools like JHSDB, it's too bad that you can't use all of jcommand's power. Ha! Says JEP 528. But what if you could? Let's recreate the JVM's memory image and execute native code in the JVM binary to interpret the data structures in that image. This enables jcommand's diagnostic commands to work exactly as they do in the live JVM with no changes to the commands or the implementation, but some limitations that I'll get to in a second. The JEP phrases this as reviving the JVM, but I don't think that's a good metaphor because the JVM doesn't really come back to life and, for example, can absolutely not execute any Java code. It's more like briefly reanimating a corpse's brain to access its memory, meaning this capability is strictly limited to post-mortem analysis of crashed JVMs. When experimenting with this, I created a little example that uses structural concurrency, so we can see something interesting in the core dump, and unsafe to crash the JVM by accessing an illegal memory location. That immediately confronted me with some limitations of this new capability though. First, the machine on which the post-mortem analysis is done must have the same operating system and CPU architecture as the system where the JVM crashed. That was not an issue for me. Second, since nobody runs macOS in production though, this feature is currently limited to Linux and Windows, which was an issue for me because I only have my very Apple work laptop with me. Thanks Anna for running the experiments on your machine. Third, I could not actually execute jcmd thread.dump2file, which shows structural concurrency relationships in its JSON output, because that specific diagnostic command is written in Java. And since this JVM is but a muttering corpse, it cannot actually execute that. Very few jcommand commands are written in Java though, so the vast majority that makes sense to execute after a crash are available. There are 26 of those, and the JEP lists them all. In my case, I resorted to thread.print. One limitation that one might expect but jcommand successfully avoids is JDK version lock-in. The crashed JDK and the analyzing JDK can be of arbitrary versions as long as they both include JEP 528. If it indeed gets integrated in 27, that means you could, for example, analyze a crashed JDK 27 with jcommand from a JDK 28 and vice versa. If you don't want to miss the JEP's integration or when some of its limitations get lifted in future releases, it hints at that in its future work section, subscribe to this channel. And if you like the feature, Java or my hyping escapades, give this video a like. I'll see you again in 2 weeks. So long.